Find the equation tangent line at a given point. We first need to find the derivative, and notice we need to use implicit differentiation. So we will take the derivative of the left side, y sine 2x, and we'll also take the derivative of the right side, x cosine 2y. On the left, we have the product rule, the derivative of y sine 2x. First, times derivative of the second, the derivative of sine 2x is cosine 2x, then chain rule says we need to multiply by 2. Continuing with the product rule, we have plus the second times the derivative of the first. The derivative of y is just 1, but we need to multiply by dy dx. On the right side, we also have the product rule. First times derivative of the second. The derivative of cosine 2y is negative sine 2y times the derivative of the inside. Derivative of 2y is 2 dy dx. Continuing with the product rule, we have plus the second times derivative of the first. The derivative of x is just 1. In the next step, we'll just clean up what we have here. We have 2y cosine of 2x plus sine of 2x dy dx equals negative 2x sine of 2y dy dx plus cosine of 2y. Remember, our goal is to isolate dy dx, so we'll move terms that contain dy dx to the left side. Terms that do not contain dy dx will move to the right side. So this 2x, this negative 2x, we'll move that over, add it over. 2x sine of 2y dy dx. And I'm just going to bring down this. Since it already has dy dx, we can leave it on the left side. Cosine 2y is good on the right side because it does not contain dy dx. And then the 2y cosine 2x we need to subtract over. The next thing we'll do is factor out dy dx. Leaving us with 2x sine 2y plus sine of 2x equals, and we'll just copy and paste the right side. And finally, to isolate dy dx, we just need to divide by the brackets. So we have found dy dx. From here, we need to figure out what that value is when we evaluate at pi halves, pi fourths. So we're looking for at pi halves, pi fourths, what is the value of dy dx? when x is equal to pi halves and y is equal to pi fourths, dy dx is the cosine of 2 times pi fourths minus 2 times pi fourths cosine of 2 times pi halves all over 2 times pi halves sine of 2 times pi fourths plus the sine of 2 times pi halves. So let's take this one piece at a time. We have the cosine of 2 times pi fourths. That's really the cosine of pi halves, which is 0, minus 2 times pi fourths is pi halves. And we have the cosine of 2 times pi halves. That's really the cosine of pi, which is -1, all over 2 times pi halves, that's going to be pi, times the sine of 2 times pi fourths, or sine of pi halves. The sine of pi halves is 1. And then we have plus the sine of pi. The sine of pi is 0. Simplifying this gives us pi halves over pi, which is 1/2. Now that we have our slope, y minus y1 equals m times x minus x1. Y minus y1. y1 was pi fourths. The slope we found to be 1/2. X minus x1 is pi halves. Simplifying this, we get y equals 1/2 x. That is the equation of the tangent line at pi halves pi fourths.